Welcome everyone for a demo of Nirnay AI Lakehouse platform. In this video, we'll see a brief explanation of what is a data lake, how data lake solves your problems, and we'll go through a brief demo of the Nirnay AI Lakehouse platform. So let's see what is a data lakehouse to begin with. Traditionally, any enterprise organization would have a need for reporting, and obviously the reports could not be executed directly from the enterprise application systems or the transactional systems. That's why the need arose to pull the data from multiple such data sources and build some reports to have a consistent visualization about what is happening in the entire organization. So traditionally, this purpose was met by a data warehouse, wherein a data warehouse application would connect to data sources, which can be your transactional systems or operational data sources, and pull those data, aggregate those data, and then present it as an output to a BI dashboard or generate some custom reports. But there were inherent deficiencies with this approach because all the processing of the data, all the pulling of the data would be required pretty often, and that would essentially take some time to process, and that data would then be available in the report. So there would be some delay. These kind of data warehouses traditionally are not online. Basically, the data is stale, and it depends on how much data you're pulling, and that will reflect on the report. So on the next page, we had data lakes, which are nothing but data warehouse kind of a solution, but it is good for structured and semi-structured and unstructured data as well. So here a data lake can connect to multiple systems, pull the data in and store it in a singular repository with a unified format, and then provide that data for any extra transform load process, provide that data as a data mart to any other process through which BI reports can be utilized, or provide that data to machine learning or data science needs as well. So this is a data lake, but the next generation is a data lake house, which is a combination of both data lake and a warehouse, where the structured, semi-structured data or unstructured data can be pulled together in a data lake house, and there is essentially no need to perform a extra transform load on the data because the data is available in a unified single format in a single data lakehouse layer. The same data source can be used directly as a source of truth for machine learning, data science, analysis, or BI reports. That is where the new generation of data lakehouse comes into picture. So let's see what are the traditional data warehousing solutions which were traditionally being used. So these systems were basically batch-based data ingestion platforms, wherein a nightly job would run to pull the data from transactional systems and generate a data model in the data warehouse. There were no real-time dashboards because the data was pulled nightly basis or data was pulled on a batch schedule. The real-time transactions were not reflecting in the data warehouse. There is a heavy load on the transactional system as well because some aggregation, some data pulling mechanisms would need to be run on the source system itself, and the queries with multiple joins or the load would affect the transactional system as well. Also, this data warehouse is not able to handle mixed types of data as well because it's predominantly connecting to, say, RDBMS systems and pulling the data. But with today's need, in today's case, where there is a need to connect to multiple systems wherein there are structured, unstructured, or semi-structured data, this data lakehouse concept doesn't fit in today's needs. And also, it is not easy to change any data model because that essentially would mean changing the underlying architecture where we pull the data from. So these traditional data warehouse solutions, although would be useful for an RDBMS structure, but it becomes difficult to scale it for unstructured or semi-structured data as well. So then came the data lakehousing solutions. Then there are data lakehousing solutions using the OpenStack solutions, like for example, Hadoop or Delta Lake or say Spark Jobs, etc. So these are available in the market. These were available since a long time, the but to implement a data lakehouse using these open source technologies is a bit challenging because we have to implement multiple technologies, like for example, a big data store like Hadoop, or a job streaming platform like Spark, or Delta Lake, which can which can run as a SQL engine on top of Spark jobs, etc. So all of these features, all of these layers would need to be implemented and would need to be maintained at the same time. And there is multiple interfaces between all of these systems, which together would make a data lakehouse. So once we do implement such kind of platforms, the idea is there are a lot of there are a lot of technologies involved here, so it becomes difficult to maintain. Also, there is no single stack where we can monitor the performance or optimize it. Since the data lakehouse becomes component based, every individual technology would need to be optimized or tweaked. Also, the deployment itself becomes costly because we would need Hadoop servers specifically for big data management. Secondly, we would need servers to maintain our other technology stacks, etc. So this becomes very difficult to implement at a scale. The third option becomes cloud-based data lakehouse architectures. Here, multiple vendors do provide cloud-based data lakehouse architectures. For example, Google does provide one, Azure provides a service, and AWS also provides a service. But all of these services are basically a combination of multiple services which are provided by the cloud vendor. For example, in this case, in Google, there is a ML service which can be utilized to perform analysis on the data lake. There is a basic data lake storage, cloud storage service which we need to use. There is a data mining service or job trigger service which needs to be utilized to push and pull the data to the data lake. There is also stream processing framework to pull and push the data from IoT streams or PubSub mechanisms. So all of these things. So to implement a data lakehouse architecture in cloud does require considerable amount of investment upfront, and also requires subscription of multiple services, which would need to be maintained and which would need to be paid for separately. So all of these things put together, we came up with a Nirnay AI Lakehouse platform, which is a combination of all of the services which are essential to manage a data lakehouse, and all of them under a single roof or under a single platform. So here we provide pre-built connectors to connect to our enterprise applications or enterprise applications like SAP or Oracle EBS, etc. Databases like Postgres, MongoDB, MariaDB, etc., or connect to IoT systems through PubSub mechanism like MQTT brokers, Kafka, etc. So this platform provides a suite of plugins and connectors which can satisfy the needs of pulling the data, storing the data in a central data lakehouse repository, providing an SQL analytics engine through which you can query the big data lakehouse, and also use the data for machine learning purposes, and also define KPIs which can be useful to measure the metrics, etc. So the Nirnay AI Lakehouse platform would basically provide all of these things together in a single platform. So this is based on open source technology of backward file systems in which we store the data in a S3 like storage bucket. We can define and we can write SQL queries in the standard ANSI format to query the data which is stored in the buckets, and basically work on large amount of data by a simple standard SQL interface. That is where the power of big data meets SQL, and that is what would be a defining use case of this. So also to reduce the load on the source systems, we have implemented change data capture technologies, which will pull incremental data from source systems so that it doesn't impact the load on the transactional systems as well. So if there is any, and this also adds real-time streaming capability. If there is a new transaction coming up in the transactional database, that can be picked and processed right away and be available in the data lakehouse to be queried and executed. So this is the main landing screen where we can define our data sets and collect the data from multiple systems. Now we can go and create a data model, which is nothing but a collection of data sources. We can call this as a data. We can call this as a data model, which is nothing but collection of data sets from from a specific domain. So in this case, let's create a subset of let's create a data model. I'm creating a data model called Oracle Web, which is nothing but data from Oracle work in progress jobs. Nothing but. So we've created a data model Now we can create data sets. This is where we create a data set. We can give the name of a data set here. I'll say this is with entities, which is nothing but work orders in Oracle. We can select the mode of the deployment as stream, batch, or one time. Stream would mean pulling the data from the source database as and when it gets created or updated. So basically, this is a real-time stream from the source data to the lakehouse. So let's select stream. We'll give a description, and let's select data source of the data. Now, in our case, the source of the data is Oracle database, since it is an Oracle ERP application. Now let's submit. So now if you see, we have created a data set. Now let's provide the run connection credentials to the database. Now let's select change data capture as our source. This means the Oracle database's redo logs would be mined to check for any new updates on the source data table, and accordingly we will be pulling the data as and when the new data set is entered in Oracle. So let's create one. In this log, we are selecting redo. So this is basically which logs to be read for Oracle, and let's submit it. So now we created a data set here, and let's enable the schedule for this. So once we enable the schedule, since this is a stream job, a task would be executed in the background, which will keep on pulling this particular table and pick any new records which come up in this particular table and insert it in our data lakehouse. Accordingly, we can create multiple such data sets and connect to any other different sources. So if we see, we have multiple options of connecting to S3, Azure Blob Storage, Google Cloud, Microsoft MySQL, Postgres, MariaDB, etc., and other connectors like Redis, MQTT, Kafka. All of these streams can be used. There are many more which can be added here. Also, we provide built-in connectors, which are nothing but geolocations data set, which is, for example, pin code and location for all the countries and its zip codes. Meteostat weather data, which is hourly, monthly weather data. In this case, we have an example of geolocations. So these are zip codes for all the countries in all the countries, time zones for all the countries, country information, geolocation. So if you can see it here. Okay, we'll enable the schedule for this to be run every 2 minutes, and we'll enable the schedule. So once the job completes for this particular data set, we'll see the records being pulled in for zip codes. Okay. Meanwhile, let's see if the data set which we created previously, if the data is flowing in there. Let's go to Oracle Web and let's see the data set which we've created, web entities. Now in this, if we click on the data tab, we can see the data which is coming up. So this is the data which has been pulled up from Oracle, and this is the live stream of the data which is coming up in Data Lakehouse. And this data can be further used downstream for any other things. We also provide a SQL editor where we can query the data sets which are coming in. So in here, if you can select Oracle Web and data set as web entities, we can see all the columns which are available, and we can write a SQL query to basically check the results. Again, we can write whatever kind of queries which we want here. So this is an example of our SQL engine. Another important thing is to create data models out of the data sets which you have created. So for that, we can go to data view collections, which is nothing but a collection of views. So we can create a new collection called Here we can add a particular view, which is nothing but based on a data set. We can select a normal view or a materialized view. And once we create the data view, we can give a query here, which will be the basis for the view. So let's test, and we can see the data is coming up here. And let's create a data model, which will be a simple data model. Now we've created a view which is nothing but a data model on how many jobs were created. Now let's create a view out of this. Now if we save this particular data model, this will get saved as a view. And once we have this view, we can create data models accordingly, and we can select all those data models one by one from here. So here, if we say select view, we can see the data model which we had created is available here. So once we can similarly connect to multiple data sources using this particular data set screen, and build data models using the data views collection screen. And using these data models, we can build any reports or build any visualizations or dashboards, which can be then further used downstream for reporting purposes. There is also a provision of creating KPIs, which are nothing but matrices which can be applied on top of data views. So let's add a KPI. Okay, if you see here, once we define a KPI, we can write any function which we want, and that function would be basically a combination of for columns in the data view and this function will be applied as a KPI to the data set itself. So let's write a simple function. Okay. So once we've created data sets and data views, we can create KPIs, which is basically measuring. We can create KPIs, which is basically measuring a particular metric in our data set. So in this screen, we can create a KPI. We can add all the formulas. We can place all the formulas or create a formula here. Add variables, local or global, which are basically used in the formula, and then accordingly use this KPI and apply it in the data view. So if you go to data views collection, if we view it here, we can in this screen apply a KPI. So in this case, if we see the test KPI which can be applied, if we pass data variables here, the column name which is available and column name which is available. So in this case, we have entity name and the variable data variable which is available, and we can test and apply this KPI. So once this KPI is applied, we can see a metric applied on the data view itself. That is how we can use KPIs. And this is a SQL editor through which we can view all the contents of the lakehouse. Okay. This is how we can connect data sets and build data models on top of it using data set collections and data views, and then query those data views and data sets in the SQL editor. Here we can query, and here we can query all the data views and collections and execute them. So this is an example of how we can connect to data lakehouse. The data lakehouse is accessible via an SQL interface to any other reporting systems as well. So for example, we can connect to Superset or Tableau directly to the data lakehouse and pull data from the data lakehouse itself instead of connecting directly to the source systems. So this is it for the demo of Nirnay AI Lakehouse platform. Thank you.